Hello, good evening, class. This is Jimo. Our topic today is still on calculus, and by the grace of God, today is gonna be the last lecture on the differentiation. So today's lecture is Maxima and Minima. So this is also one of the applications of differentiation under calculus. So without wasting much time, I'm gonna go straight to some definition of terms. So in this lecture, under this topic, there are two important terms that you need to know. One of them is gradient, which is the same as slope. So from your secondary school days, if you are finding gradients, it used to be y2 minus y1 over x2 minus x1. So this is approximately equivalent to dy dx. So please take note of that. If a question asks you to find the gradient or the slope of something, it's just indirectly asking you to find dy dx, provided that you are given the relationship between y and x. So the second important term here is stationary point. Stationary point is also called turning point, and we can simply define this as a point where tangent to a curve is parallel to the x-axis. This is not the important aspect of this term. The important aspect of it is this expression. At the stationary point, dy dx is 0. dy dx is 0. Now this third point, the third term that I have defined here, is explaining stationary points. So stationary points can be maximum or minimum. It is maximum when the second derivative of y with respect to x is less than 0, and it is minimum when second derivative of y with respect to x is greater than 0. So you will be coming across questions that will ask you to find the maximum value of a function or the maximum value of x at which a function is so and so. So we are going to take some examples, and from that example I'm sure you're going to understand better what I'm trying to say about this definition. So let's go to some examples. Example 1. This was taken from UTME 2010, paper type B, and is question 42 of that year. So the question is, at what value of x does the function y equals minus 3 minus 2x plus x squared at a minimum value? So the question is, at what value of x is this function at a minimum value? That is the question. So let's see how we are gonna solve this one. So score booster solution is like this. First of all, we rewrite the function, and since we are talking about maximum, we are talking about minimum, so the first thing to do is to find the derivative of this function. So we have dy dx is equals to, if you differentiate a constant, it is 0. Differentiate 2x. I hope we can still remember differentiation. So if you differentiate 2x, you're gonna get 2, right? And if you differentiate s squared, you're gonna get 2x. So from our definition, we know that at the minimum point, dy dx is equals to 0, right? So it means we can remove dy dx and put 0, and that is what I have done here. Meanwhile, I have simplified this function. 0 minus 2 is 0, so I'm gonna have, it's minus 2, so I'm gonna have minus 2 here plus 2x is equals to 0, right? So what are we looking for? The question has requested that we find the value of x. So what we're gonna do here is just try to simplify. Okay, you can add 2 to both sides, and from there you're gonna have 2x is equals to 2, or x is equals to 2 over 2, which is equals to 1. As simple as that. Now let us see, sometimes the same question can be repeated and it will come in a different form. So let us see, this question was repeated in 2014, but it was framed in a different way. So you need to be careful. You need to understand the question and take a good grab of it and know how to solve it. Look at the question in 2014. The example 1 was in 2010. And now example 2 is the same expression and in 2014, but we're going to see what is the difference between the two. So UTME 2014, paper type X, question 40. So find the minimum value of y equals x squared minus 2x minus 3, the same expression, right? Now please take note, find the minimum value of y is equals to this. So you know that this question is not asking for x, rather it is asking for y. So let's go. This is the solution. ScoreBooster solution. The expression has been rewritten and we find dy dx, okay, but at the minimum value we know that dy dx is equals to 0, so we can have 2x minus 2 equals 0, and x is equals to 2 over 2 and is equals to 1. So I am trying to still sound a note of 1 in here. This is not the final answer. You are to find y but not x. Unfortunately, after getting to these points, if you look at the option, you are going to see 1 there. It is just to deceive those who don't know what they are doing, right? So you keep working, and let's see. So now we find the value of x. So from there we can substitute and get the value of y. Look at the initial expression, y is equals to x squared minus 2x minus 3. Now you have x, so you can substitute for your x in this expression, and this is what we are gonna get. So we're gonna have 1 squared minus 2 times 1 minus 3. 1 raised to power 2 is still 1. 2 times 1 is 2, and minus 3. So you have 1 minus 2 minus 3 is minus 5. So 1 minus 5x minus 4, and this is the final answer. So you can see same question but differently framed, so you need to be careful. Another example 3. This is 2009, question 39. The distance traveled by a particle from a fixed point is given as s equals t cubed minus t squared minus t plus 5 centimeter. Find the minimum distance that the particle can cover from the fixed point. So this is as if you are given y is equals to s cubed minus s squared minus x plus 5. So it's just a change of symbols or letters. So let's see how to go about this. We have to find the minimum distance. You know that minimum distance here means s, so it means you find the minimum value of t, and it is that minimum value that will make s to be the minimum distance. Okay, so let's look at it. ScoreBooster solution goes thus: the expression is repeated and we differentiate it. ds dt is equals to, we differentiate this one, you have 3s squared, differentiate this, you have 2t, and differentiate t, you have 1, differentiate 5, you have 0. So I don't need to write that. So at the minimum point, ds dt equals 0, right? Therefore the whole of this one will be 0, so I can put my 0 here. So I have 3t squared minus 2t minus 1 equals 0. So this is a quadratic equation. So if you have forgotten, you need to just take a little revision of how to solve quadratic equation. You can use the so-called almighty formula, it's okay. So but I'm using factorization here. So you have you split this one, minus 2t is the same as minus 3t plus t. So you pair the two values, you can see here that 3 is common here and t is also common, so I can bring that out. So I have, after bringing out 3t, I have t minus 1, then 1 is also common here, 1 here and 1 here. So if I bring out 1, I have plus 1 into t minus 1. So again, what is common? T minus 1 is common. So if I brought t minus 1, I'm gonna have 3t plus 1 here and t minus 1. So more or less there's going to be two values of t. Okay, so at this point you have 3t plus 1 into t minus 1 equals 0. So this kind of statements is possible if 3t plus 1 is equals to 0 or t minus 1 is equals to 0. So if 3t plus 1 is equals to 0, then 3t is equals to minus 1 or t equals 1 over 3. And if t minus 1 is equals to 0, it means t is equals to 1. So one way to look at this is to assume that t can never be negative. So if we take t is equals to 1, then you substitute to the expression of the distance. So you have 1 is equals to, s is equals to 1 raised to power 3 minus 1 raised to power 2 minus 1 plus 5. 1 raised to power 3 is 1. 1 squared is 1. And you have this minus 1 here and plus 5. So what you have here is you can collect the like terms to make things simple, or you can further simplify. Minus 1 is minus 2. Then look at the like terms. This is positive, this is positive. So you can bring the two positive numbers together to make 6. 1 and 5, 6. Then minus 2 here. So minus 2 plus 6 is equals to 4. So this is the minimum distance. So let's look at another example. Before I go to that example, I want to tell you that it's possible that this example 3 can be repeated, and in that case it might be reframed in such a way that they can just ask you, at what time could the particle cover the minimum distance from the fixed point? You see, the question is at what time. It means you just need to find only t, and that will be your answer. Take note of that. So example 4, this is from UME 2001 and is question 37. So find the dimension of the rectangle of greatest area which has a fixed perimeter. The question is just, I don't know, short, and sometimes the first time you look at it is meaningless. What is this? Okay, so let's see how to go about it. So this is the ScoreBooster solution. So for a rectangle, we know that the area is length times breadth, and we represent the length as L and the breadth as B. So area equals LB. So we make that one equation 1. Again, for rectangle, the perimeter is 2 into L plus B. Let that be equation 2. Right? Now for this rectangle to have the greatest dimension, it means we're gonna look for the point where the derivative of A with respect to L is equals to 0, or derivative of A with respect to B is equals to 0. So if I take the derivative to be with respect to L, for example, so from equation 2, from this equation, I'm gonna have my B to be equals to P over 2 minus L. Let that be my equation 3. So if I put this equation 3, this B, if I substitute into 1, it means I should be able to eliminate B, right? So my A then becomes A equals to L into P over 2 minus L. If I open the bracket, so I'm gonna have PL over 2 minus L squared. So we should pay attention here to the statement in the question that P is fixed. That means the perimeter P is a constant. So if we are differentiating it, we don't touch it since it's a constant. So we have, now from here we have A is equals to PL over 2 minus L squared. So we differentiate A with respect to L using this expression. So we have dA dL is equals to P over 2, which is a constant. If you differentiate L here, you get 1. So differentiate L square, you get 2L. Now at the greatest area, dA dL equals 0. Therefore P over 2 minus 2L equals 0. And if you simplify things, you're gonna get 2L is equals to P over 2, and your L is equals to P over 4. So already we have B. Okay, from here B is equals to P over 2 minus L. So we can substitute for B in that case, and what are we gonna have? Okay, we're gonna have it that B is equals to P over 2 minus L, and what is our L? Our L is P over 4. So P over 2 minus P over 4. Find the LCM and do further simplification. Our B is also equals to P over 4. So the dimension of our rectangle, which is given as A equals to L times B, is going to be P over 4 times P over 4, and that will be P over 4 all squared, right? So the answer as put in the option is square of sides P over 4. That is all. So this brings us to the end of the questions and solutions. So the next thing now is exercise, where you are going to try your understanding of all I have taught today. So these are the exercises. I have 3, and they are all from past JAMB questions, UTME questions, and the answers are there. So I will advise you to try your hands on them, and if you find difficulty in any of these questions, just shoot me an email in any of my contacts. I will be there for you. So by this I say thank you very much for listening, and see you next time when I'm gonna start with integration. So as I said, this is the last topic in differentiation, so catch you in integration. Thank you.